Extension of Hector-Olym theory. Friends, today we are going to look at some dynamic factors in international trade. Let me introduce you to the topic. The Hector-Olym theorem is based on highly restrictive assumptions that there are two countries where quantities of labor and capital are fixed. Tastes are unchanged, technology and returns to scale are constant, and transport costs are zero. In reality, all these factors which affect trade are constantly changing. It is therefore useful to relax some of these assumptions in order to study the impact of changes in factor endowments, tastes, transport costs, technology, etc. on international trade. Now friends, let us have a look at changes in factor endowments. When there are changes in factor endowments of a country, given no change in technology, they bring about changes in output, volume of trade, income, employment, terms of trade and gains from trade between two trading countries. In order to analyze the impact of changes in factor endowments on these variables, let us consider a case in which the supply of only one factor increases in one country with no change in the supply of factor in the other country. Now friends, let us have a look at the impact on output. Let us consider the case of a country A where there is an increase in only the supply of labor endowment. Commodity prices remain constant. An increase in the supply of labor increases the output of the labor intensive commodity, say X, and reduce the capital intensive commodity, say Y. This is explained in terms of figure 1, where at the horizontal axis measures quantities of the labor intensive commodity X and the vertical axis of the capital intensive commodity Y in country A. Its initial production possibility curve is KL and the production point is E, where the price line PP is tangent to the KL curve and it produces OX of X and OY of Y. When the supply of labor alone increases, the production possibility curve KL shifts upwards to K1 L1. The price line P1 is tangent to the curve K1 L1 at the production point E1, where country A produces OX1 of X and OY1 of Y. The comparison of 2 points E and E1 shows that after the increase in the supply of labor, the output of labor intensive commodity X has increased from OX to OX1 and that of capital intensive commodity has decreased from OY to OY1, even though the supply of capital has remained unchanged. Now friends, let us have a look at the impact on volume of trade. If a country A exports commodity X, an increase in the supply of its relatively abundant labor endowment tends to increase the volume of its exports. This can be seen in figure 1. Suppose before the increase in the supply of labor, A was exporting OX quantity of X to country B. With an increase in the supply of labor, A's production possibility curve shifts upwards to K1 L1 from KL and the new production point is established at E1 on the P1. As a result, its exports of labor intensive commodity X increases from OX to OX1. Thus, it is able to increase the exports of X more than proportionately to the reduction in Y. Now friends, let us have a look of it, impact on national income. An increase in the supply of labor and consequent outward shifting of the production possibility curve implies an increase in the national income of country A. This can be explained with the help of figure 2. The initial production possibility curve is KL with an equilibrium point A. When the supply of labor increases, the new production possibility curve is K1, L1. The higher the production possibility curve, K1, L1 implies an increase in national income. The new equilibrium position is at A1, where the price line P1 is tangent to K1, L1 and is parallel to price line P. But A1 cannot possibly be an equilibrium point at the higher national income level, except if Y is an inferior good. At point A1, the output of X increases and that of Y decreases. Therefore, the new equilibrium point must lie within the quadrant QAR on the K1 L1 curve. Therefore, the point of equilibrium will be B, where both X and Y are produced more. Now friends, let us look at its impact on employment. Given factor and commodity prices, when the supply of labor increases in country A, there will be transfer of labor from capital intensive to labor intensive industry. This is explained with the help of figure 3, where origin of commodity X is O and of commodity Y is O1. Country A's factor endowments are measured by the box OLO1C. With the increase in labor by LL1, the new boxes OL1, O2, C. Initially, A produces at point A on its contract curve OAO1, where it produces OA of X and O1A of Y. With the increase in labor supply, it produces at A1 on its contract curve OA1, O2, where it increases its production of X from OA to OA1 and reduces its production of Y from O1A to O2A1 with no change in factor and commodity prices. The increase in production of X by AA1 has been possible by transferring some of labor from the capital intensive industry to the labor intensive industry X. Now let us have a look at impact on gains from trade and terms of trade. In figure 4, as we can see, OA is the initial offer curve of country A. At the equilibrium point E, with terms of trade OT, it exports OX of commodity X and imports OY of commodity Y. As a result of increase in supply of labor, its offer curve shifts from OA to OA1 at constant terms of trade OT. The new equilibrium will be at point E1, where country A exports X1 more of X and imports Y1 more of Y. But at constant terms of trade, it does not gain from trade because it must offer more X per unit of Y than before. In this situation, the terms of trade move against country A from OT to OT1. The new equilibrium is on OT1 with the OA1 offer curve at E2, where A gains more from trade by exporting larger quantity XX2 of X in exchange for lesser quantity YY2 of Y. Thus, its terms of trade also improve. Now let us look at its impact on economies of scale. The Heckscher-Ohlm theorem assumes constant returns to scale in the production of two commodities that are traded by two countries. It means that the average cost and the marginal cost of producing the two commodities remain constant as production increases. This is unrealistic because cost functions in many developed countries have decreasing costs or increasing returns to scale. Increasing returns to scale may be due to internal or external economies. External economies are consistent with perfect competition because these occur when all firms in an industry simultaneously experience a lowering in their average costs as their level of production expands. Now let us look at its exact explanation. Given these assumptions, trade would not be possible according to the Heckscher-Ohlm theorem. But if both X and Y commodities are produced under decreasing costs or increasing returns to scale, trade is possible between the two countries. Country A will specialize in the production of X and B in the production of Y. A will exchange a part of its output of X with a part of the Y output of B. As a result, the level of consumption rises in both the countries. As total production of both X and Y increases due to external economies of scale, both A and B countries gain from trade. In figure 5, B and A is the production possibility curve of both A and B because both countries are identical. Since they have identical tastes, they have the same community indifference curve CL. Thus, in the pre-trade situation, each country produces and consumes at point N. If the two countries trade, A completely specializes in the production of commodity X, shifting production from N to A, while B completely specializes in the production of Y, shifting production from N to B. Trade can take place between the two countries based on decreasing costs, even though the relative commodity prices are identical in both at point N. Given the international price ratio, terms of trade, BEA, a feasible equilibrium would be point E, with trade triangles BEC and EAD. Country A exchanges DA of X with country B's CB of Y. Due to increased specialization, both countries consume more, being at point E on the higher community indifference curve CL1. Thus, both countries gain MD of X and LC of Y. Now friends, let us have a look at changes in tastes. The Heckscher-Ohlm theorem is based on the assumption of constant tastes. But what happens if a country's tastes change given its technology and factor endowments? A change in tastes will alter its volume of trade and terms of trade. If a country's tastes changes from its exportable to importable commodity, its volume of trade increases and its terms of trade declines. On the contrary, a change in tastes from its importable to exportable commodity reduces its volume of trade and improves its terms of trade. This is explained in terms of the offer curves in figure 6, where OA is the offer curve of country A and OB of country B. With unchanged tastes, A exports OX of X and imports XE of Y. Suppose tastes in country A changes from its importable commodity Y towards its exportable commodity X. Its factor endowments, technology, etc. remain unchanged. This shifts its offer curve OA to the left OA1 because its need for Y has become less intensive. It will now offer less of X than before in exchange for Y to country B. Thus, at its new equilibrium point E1, where the offer curve OA1 cuts the offer curve OB, country A exchanges OX1, its exportable commodity X, for X1 E1 of Y. As a result, its volume of trade has declined with change in tastes. That is, OX1 plus X1 E1 is less than OX plus XE. But its terms of trade have improved, as shown by the terms of trade line OT1, whereby it exchanges less quantity OX1 of X in exchange for a larger quantity X1 E1 of Y. Now let us look at differing demand conditions. Both the classical and Heckscher-Ohlm theories do not consider the influence of demand on international trade. But given the supply conditions, differing demand pressures may lead to differences in price ratios in the two countries and to exchange of commodities between them at world price ratio. This case is explained in figure 7. Suppose there are two countries, country A and country B, with a common production possibility curve AB. In the pre-trade situation, different demand conditions relating to commodities X and Y have different relative price ratios, as shown by P1 in country A and P2 in country B. The consumption and production point of A is F, where its CL1 curve is tangent to the production possibility curve. Similarly, the consumption and production point of B is K, where its CL2 curve is tangent to the production possibility curve. As is clear, A specializes in the production of capital intensive commodity Y and B in the labor intensive commodity X. When trade begins at the international price ratio P, both countries would specialize in the production of both commodities and their production equilibria would converge on point E. As a result, the consumption level of A shifts upwards along the price line P at point G, where it is tangent to the higher CL3 curve. Similarly, the consumption level of B shifts to higher level L, where P is tangent to the CL4 curve. Both points G and L show the pressure of higher demand for both commodities in the two countries. Trade between the two countries will be on the basis of trade triangles, which are GED and ELH. Now country A exports DE of X for HE of Y of country B. Thus, with increase in demand, the capital intensive country A exports the labor intensive commodity X and the labor intensive country B exports the capital intensive commodity Y. This is the case of demand reversal, which also explains the Leontief paradox. Now let us look at its impact on the transport costs. The Heckscher-Ohlm theory assumes zero or no transport costs. This is unrealistic because transport costs are important in their impact on the price of a traded commodity, its production and consumption and volume of trade in two trading countries. Transport costs include all expenses incurred in transporting a commodity from one country to another. They include loading, unloading and freight charges, insurance premium and interest costs. With the inclusion transport costs, a commodity will be traded only if the price difference between two countries before trade is more than the cost of transporting it. Now let us look at its explanation. The effects of transport costs on these trading countries are explained with the help of figure 8. The price of steel is measured vertically on a common axis O. The demand and supply curves are shown by DA and SA for country A and DB and SB for country B. Before trade, each country produces the quantity at price determined by the intersection of respective demand and supply curves. It is OQA quantity at QAE price in A and OQB quantity at QBE in B. When trade begins at A, will export steel to B. As a result, the price rises in country A and falls in country B. For the market to clear under perfect competition, there has to be same price in both the countries. It is shown by the horizontal lines P5, P5. This line cuts DA and SA curves of country A and A1 and A2 and SB and DB curves at country B at B1 and B2 respectively. Country A produces OSX, consumes ODX and exports DX, SX, while country B produces OSM, imports SM, DM, which is further equal to DX and SX, and consumes ODM. When transport costs are introduced, the exporting country regards them as equivalent to a reduction in the price of steel by the amount of transport costs. On the other hand, the importing country regards them as an increase in the price by the amount of transport costs. This decrease and increase in the price of steel is on the previous trading price, which is P5 in the figure, so that the volume of trade is in equilibrium in the two countries. This occurs when the price P4 cuts DA and SA curves of country A at A3 and A4 points respectively. Country A produces OSX1, consumes ODX1 and exports DX1 minus SX1. On the other side, in country B, the price line is P6, which cuts its SB and DB curves at B3 and B4 points respectively. Country B produces OSM1, imports SM1 minus DM1, which is just equal to DX1 minus SX1, and consumes ODM1. In the above case, the transport costs are shared equally by each country because the slopes of D and S curves in the two countries are the same. If the slopes of the D and S curves of one country in relation to the D and S curves of the other country are drawn more steeply, the share of the transport costs will fall on the first country. Friends, let us summarize today's session. As we know, according to Heckscher-Ohlm's theory, a capital abundant country will export the capital intensive good, while the labor abundant country will export the labor intensive good. But due to Heckscher-Ohlm's model's highly restrictive assumptions, it fails to explain the impact of changes in other factors such as changes in factor endowments, tastes, transport costs, technology, etc. When a country's factor endowments change, it brings about a change in terms of trade, output, gains from trade and employment. Transport costs of a commodity includes all expenses incurred in transporting a commodity. Hence, due to inclusion of it creates price difference between two countries. An increase in labor supply shifts the production possibility curve outwards and therefore increases the national income of the country. Improvements in technology shifts the entire production possibility curve outwards, thus raising the economic growth and improves the terms of trade and gains from trade. So friends, we have seen in today's session that changes in factor endowments, differing tastes, transport costs, technology, etc. do have an impact on output, volume of trade, income, employment, terms of trade and gains from trade between the two trading countries. Thank you.